Day 10 notes, your last ones from Chapter 7. Kind of like this set of notes. It gets a little tricky at the end, but up till then, we're going to look at some word problems, some more drawing, making sure we're good at drawing, and then we're also going to look at some area problems. So, Michael Jordan is 6 feet 6 inches tall, 6'6", from North Carolina, for those of you who are Bulls fans. He has a shadow of 2 feet 1 inches. I should have said 1 inch, it's alright. If he stands next to Nate Robinson, I made this last year when Nate Robinson was actually on the team, who is 5 feet 7 inches tall, how long is Nate's shadow in inches? Round to the nearest tenth. Alright, so let's get ourselves a picture. So we have Michael Jordan. And his shadow. His shadow is not in the air. Some people think shadow's in the air. The sun's here, we'll say, or the light or whatever it is, creating a shadow over there. We have Nate Robinson, who's a little bit shorter, and his shadow is not going to go as far out. And no, I didn't just draw them with a black marker because they're black, for those of you thinking that right now. So, Michael Jordan. So MJ's over here. Nate Robinson's over here. Michael Jordan is 6 feet 6 inches tall. So, 6 feet 6 inches tall is really 6 times 12 is going to give us 72, plus 6 inches is 78 inches. So I'm not going to look at that anymore. He has a shadow of 2 feet 1 inches, so his shadow is actually pretty short. Okay. So the shadow is 2 feet 1 inches, which is 2 times 12 is 24, plus 1 is 25 inches. If he stands next to Nate Robinson, who is 5 feet 7 inches tall, 5 times 12 is 60, plus 7 is 67 inches. How long is Nate's shadow in inches? Round to the nearest tenth. Okay, so make sure our labeling is done correctly. We have Michael is 78 inches tall. His shadow is 25 inches tall. Nate Robinson has a, or we want to figure out what his shadow is, but he is 67 inches tall. How long's his shadow? Well, quite a few ways you can write this. I'm going to go ahead and make it 78 over 25 equals, actually no, I don't like the way that looks. Some of you could have done that and maybe did that. 78 over 67 equals 25 over x would be one way you could do it. So everything's in inches, so we should get an answer in inches. So we get 78x equals, let's see, 67 times 25. Holy cow, 1,675 divided by 78. I told you guys to round to the nearest tenth, so if you're done, round to the nearest tenth. We get x is about 21.5 inches, which makes sense because Jordan's is 25 inches. Nate's has to be a little bit shorter of that because Nate Robinson is smaller than Michael Jordan. Okay, so here's one example. Number 2, how tall is the tree? So we've actually seen some examples like this without word problems. We have a little stick figure. Good thing I didn't draw it. That's why I Googled it and got a little picture so I could draw or have a nice little stick figure. How tall is this tree? So that's our x. Okay. Redraw the big triangle. You can see the little one, 5, 8. Let's look at the big one so we can see everything a little bit nicer. So I'm going to go ahead and redraw the big one. It's not going to be as big because it's going to take up too much room. So I'm going to redraw the big one. The big one is, here's your tree. Oops, that's not a tree, that's a person. Here's your tree. Okay. We want to find out x. The whole length is 24. Again, I'm going to get rid of that because now I'm just going to focus on this triangle. Whoops. Sloppy. And this triangle. A couple of proportions that would work. I'm going to go ahead and make it 5 over x equals 8 over 24. Cross multiply, so you get 8x equals, that comes out to be 5 times 24, I believe is 120. Divided by 8. X is going to be equal to, so 120, oops, 120 divided by 8 gives you 15. So 15 feet tall. Okay, give me a unit with that. The scale on a map of downtown Chicago is 1.5 centimeters to 300 meters. If on the map Union Station is 12 centimeters away from Greektown, find the actual distance between Union Station and Greektown. Okay, so again, a few different ways you can do this. 1.5 centimeters to 300 meters. That's our scale. So I'm going to go ahead and make it scale is 1.5 centimeters to 300 meters. Okay, so if on the map Union Station is 12 centimeters away, how far away is it in real life? Okay, so that's how you kind of want to think about these problems when you're setting them up. Most of you have gotten very good at them. Some of you still need a little bit of practice. So let's see, 12 times 360, that's easy enough to do. So we get 1.5x equals, let's see, that's going to be 3,600 divided by 1.5. So that's going to come out to be 2,400, and that would be meters away, because it converts it back. Okay, because centimeters are on top, meters were on the bottom. It'll work out so it converts it right back to meters for you. Moving on. Find the scale factor if, given ABC is similar to DEF. So A to B to C, D to E to F. It's all in the right order. Just find the scale factor. Okay. So 3 over 6 is equal to 4 over 8 equal to 5 over 10. Do those all give you the same ratio? Well, 3 sixes, 1/2. 4 over 8 is 1/2. 5 over 10 is 1/2. So scale factor from ABC to DEF is 1/2. So just throw in a little easy one in there for us. Alright, similarity in perimeter and area. Okay. If the scale factor, or the similarity ratio of two similar figures is A to B, then the ratio of their perimeters is A over B, and the ratio of their areas is A squared over B squared. So perimeter stays the same, the ratio stays the same. The areas is squared, and I'll show you why here in a second. So let's just look at a rectangle, because we all know a formula for a rectangle. So let's just say we have two rectangles. Okay, and we'll say that the sides are 4 and 8, and we'll say that this ones are 2 and 4. Okay, which means this is 4, this is 8, this is 2, this is 4. And we're just going to take a look at what this means here. So if I were to ask you to find the scale factor from big to small, you would do 4 over 2 is equal to 8 over 4, just matching up sides. You don't have to do it again because that would just be more work. 4 over 2 is equal to 2 over 1. 8 over 4 is 2 over 1. There's your scale factor from big to small. So that's your scale factor of your sides, or your ratios. Let's look at the perimeters now. Well, the perimeter of this one, you guys can add that up real quick. So we have 8 plus 8 is 16, plus 4 plus 4, that's going to be 24. Over here we have 4 plus 4 is 8, plus 2 is 12. So your perimeter ratio is 24 over 12, which is equal to 2 over 1. So the ratios of the perimeters match the ratios of the side. Now, let's look at the same exact problem, and we'll say that if we're looking at the areas, so let's look at the same one, and we'll say this is 2, 4, 2. Actually, I don't want to draw it that big. Sorry. Let's start with this one first. 4, 8, 4, 8, and a little bit smaller. 2, 4, 2, 4. So we've already said the ratios of their sides are, and their perimeters are 2 to 1. So let's look at the areas of the ratio of their areas. So area, to find a area of a rectangle, it's 4 times 8, or 32 centimeters squared, or units squared, inches squared, whatever it is. 2 times 4 is 8 inches squared. So the way you do this, the ratio of their areas, you would say, is 32 over 8. You would reduce that to 4 over 1. So that would be their area ratio. So to really get from your perimeter ratio to your area ratio, or your scale factor, if you want to think of it like that, you take 2 over 1, you square the top, you square the bottom. 2 squared over here becomes 4. 1 squared becomes 1. That is your area ratio. And we're going to look at a couple of these here to help further explain that. So, the ratio of the sides of two similar triangles is 5 to 7. What's the ratio of the perimeters? It would be, so if the ratio of the sides are 5 to 7, the ratio of the perimeters is the same, 5 over 7. The ratio of the areas would be 5 over 7 squared, which is equal to 5 squared is 25, 7 squared is 49. That would be your area ratio. Okay, so it squares the top, it squares the bottom. That's where we're getting inches squared from, centimeters squared from. That's not a coincidence. That's why we square things, because things get squared bigger. Given that, now we'll look at an example. RST is similar to UVW. RS is 16. Perimeter of RST is 36. Area of RST is, I'm going to draw this bigger so I can fit more stuff. So we have perimeter, area. This was RST 16. Perimeter is 36. Area is 48. UV is 20. Draw a diagram and then find the perimeter and area of UVW. So what we're going to do here is find first the scale factor from one to the other. We already have the sides that match up, so we have these sides match up. The scale factor is 16 over 20, which is equal to, if you divide that and you simplify math frac, however you want to do it, that's 4 over 5. So that's the scale factor from small to your bigger one. So what we said before is that the scale factor for your perimeters remains the same. It's just A over B. So if the scale factor is 4 over 5, that's the same for your perimeter. So we would say something like, I'll do this in a different color, 4 over 5 is equal to, well, if my small one's getting 4, my big one's getting 5, when my small triangle gets 36 feet, what is this all in feet? What's the perimeter of my big, so I'll call it P. What's the perimeter of my big triangle? Cross multiplies, so that comes out to 4. P equals 36 times 5 is going to give you 180 divided by 4. P is going to be equal to 45 feet. So that's your perimeter. Okay, so it takes on that same ratio. Now to figure out your area, a little bit different. We said before you take your scale factor and square the top and bottom. So what we're going to do, instead of it being 4 over 5, we're going to take that and square it. 4 squared over 5 squared equals 16 over 25. That's the scale factor we're going to use. So 16 over 25 is equal to, okay, area for the small one is 48. This is all in feet again. We're going to have to figure out what the area for the big one is. And again, now it's the same thing. Cross multiply, so we have 25 times 48, 16a equals 1200. Divide by 16. Hopefully it comes out to a nice number, and I believe it does. It does. 75 feet for your area of your big one. 75 feet squared, because it's area. Okay, because again, we're squaring it. So again, your ratio remains the same for perimeters, but it's squared when you go to area. Let's make sure you guys get that stuff down. We're going to look at number 8 in class together, but we're going to do number 7 here. Given ABCD is similar to EFGH, find X and Y. So, what we've got here are areas for both rectangles. Again, if we're given the area, then we want to go and convert it to a scale factor. So what we have right now is that from big to small we have a area ratio of 120 over 67.5. Let's hit MathFrak and see what that comes out to be. So 120 divided by 67.5. We do MathFrak. That's going to come out to be 16 over 9. So that's really equal to 16 over 9. But remember, our area ratio was squared. So how do we get rid of squaring something? Well, we take the square root. The square root of 16 is 4. The square root of 9 is 3. So that's our scale factor that we need to use for this particular problem. So that's our scale factor. Now what we do is just set up a proportion that works to find X, and then we'll worry about Y. So what we're going to say here is that 4 over 3 is equal to 2x over x plus 3. Okay? Scale factor sticks together. 2x goes with x plus 3. 2x is bigger than x plus 3. Cross multiply. So you get 4x plus 12 equals 6x. 12 equals 2x. X is 6. So this side, we already found x now. This side is really 12. This side is 6 plus 3 is 9. And to figure out your last step, we'll see what you guys can think here. We know one side of a rectangle. We know the area. We don't know the other side. So hopefully you're thinking how you might be able to find the other side. If not, I'll help you guys get started. Area of a rectangle equals length times width. We know the area. We know the length is 9. We don't know what that width is. That width is really y. So I should put a y there instead of a w. So we have 67.5 equals 9y. Divide both sides by 9, and 67.5 divided by 9 comes out to be 7.5. That would be inches there. Inches. Right. So again, we took our original area ratio. That was squared. To get rid of squared, we square rooted it to get to 4/3. Then used 4/3 to set up for x. Plug x back in, and then lastly you're using your rectangle formula to get back to y. We're going to save 8 to do in class together, because this is a little bit tricky. Hopefully the word problems at the beginning weren't too bad, but this is a little bit tricky with your area and ratio and going back from one to another. So we'll take a look at number 8 tomorrow in class. You don't need to have it done. And then again, this is the last set of notes. You'll have some supplemental videos in the video or in the folder, so you can look at. I think I put side splitter in there, and then a couple other teachers helped me make some more videos for a couple other topics. Those will be labeled in your folder as well. Last one from chapter 7. See you guys tomorrow.